Hello friends, how are you? In this video, we'll discuss about function, Python function. So what is a function? If a group of lines is required frequently, it is not obvious to write them separately each time. Okay. These statement must be defined as a single unit, which may call any number of times based on our requirements without having to rewrite. This is called function. Okay, suppose we have a suppose 10 lines are there. Okay, and we need these 10 lines in 100 lines. Suppose a main program is there, is a main program. Here we need such type of code. Suppose it is a square root. Okay, suppose it's a square root. We need square root 3 times. Okay, so we need in this particular part, in this particular part, in this particular part. So no need to write that 10 lines program all these in these 3 times. What we have to do, we just create a function. We have just write a function and keep it in a module. Okay, keep it in a defined as a single unit. Okay, and whenever it is required, we can call it and we can use it. Okay, we can call it, we can reuse it. We can call it and we then can reuse it. So question is, if you do not use function, then what will happen? So basically, total number of main programs say 100 lines, and we need this 10 lines 3 times. So total, if you do not use function, total number of lines should be what? It is 130. But if you use function, we need what? 100 only plus 10, that is 110. That 130 minus 110, that is 20 number of uh, 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 less lines we required if you use function. Okay. Now, one line is there. Functions are also called methods, procedures, or subroutine. So it is also called methods. Sometimes we call it a procedure. In another language, it may be called, so it is subroutine. Now, types of functions. There are two types of function: built-in functions and customized functions. What is a built-in function? Built-in functions or predefined functions are functions that are automatically included in with Python program. So it's automatically included. For example, printf, print, max, min, power, input, etc. So in Python 3, there are 68 built-in functions. So you can Google it and you can get how many built-in functions are and what are these. So we'll concentrate user-defined functions only. So what do you mean by user-defined functions? User-defined functions are the functions that are written explicitly according to requirements by programmers. Okay, so it is what it is written by the programmer and based on the requirement. So what is the syntax of the function? So here we have to write def, def. Here we have to write the function name. Parameters, it's optional. You may pass or you may not. There is a code of the function and return values. It is also optional. We may return or we may not. Okay. So suppose we want to add a two number. So what you have to write? So def. Okay. Suppose sum number. So this is function name. Suppose two parameters are there, a and b, then colon. So definitely you should not forget about this colon. Then we have to write x is equal to a plus b. Then we have to write return x. So definitely we have to write this one, name of the function, parameters, body of the function, and the return x. It's a return value. So this one is the optional and return value is optional, but definitely we have to write this one and the function name. Okay. So this is what our syntax, basic syntax. So we can see some example. So we can see one example. Suppose function definition. So my function. This is what function definition. Okay, so function definition is what? So in a function, two part are there: function definition and the function call. Okay, so function definition, def my function is the name of the function. Here colon is there. So here no parameters, we are not passing any parameter, and print is what? Humanity above all. Humanity above all. It is just, we just print the output. Function call, so we can pass the value, we can pass the value, or we can call the value. So instead of doing this one, what we can do, we just do one thing. We just initially just call this, just we can call it. If you call single time, we can get the single time output. Okay, for the timing, we just, okay, and if you execute it, okay, so invalid syntax, humanity above all. Here we have to put one, this one, and this one. Okay, and you can run it. The output is what? Humanity above all. Okay, so that means what? That means what? Here is a function calling. When you call the function, that means we want to use this particular function. So by calling the function, we can use the function. If you do not call it, we cannot use this particular function. So whenever you call my function single time, it will execute this particular part and it will print humanity above all. So we can call this particular function many times, as many times. Okay, so we can see here, suppose we want to call this particular function. Suppose now we can suppress it, and we can this one and this one. Okay, so here we want to call this particular function 5 times. Okay, and so what you can do, we can call it, now you can execute it. Now you can see here, same function we are calling 5 times. Same function we are calling 5 times. Okay, now we can see, we can discuss about the parameter. Parameters of the function's input. If a function has parameters, we must specify values when invoking the function. Otherwise, we will receive an error. Okay, we can see example. Suppose this is what our function definition, line number 2. So this one, 2 and 3. This is what our function definition. So def my function name, print hi name, how are you? So this is what name of the function. Your name is the parameter. We are passing this function, and print hi name, how are you? And here name is the formal parameter, it is also called formal parameter. And here no return value is there, so default return value is none. Explicitly we are not returning anything, then default return value is none. So we are calling this particular function 2 times. So here we are first time we are passing Kapil, second time we are passing Sachin. So this Kapil, Sachin, both are called the actual parameters. Okay, so my function Kapil means what? Hi Kapil, how are you? First time it will execute. Second time Sachin, hi Sachin, how are you? Okay, so we can see the output. Now if you execute it, so you can see this output. Now instead of Sachin, we can write say hi Rani, and we can execute it. So now the output is, you can see the output, hi Rani, how are you? Okay, so this is what our function call. Here we pass the parameter. This parameter is called the actual parameter. We are calling this particular function that Kapil will pass, this particular will pass in the name. This is what our formal parameter. Now the output will be what? Hi name, how are you? If the name is Kapil, the output will be hi Kapil, how are you? If the parameter is Rani, hi Rani, how are you, and so on. Okay, so if it is in a function, suppose one function is there. If it is if a function is there, there must be some input and there must be some output. So if input is there, it is called the parameter. Okay, so and if output, it is called the return value. Okay. Now you can see another example. So this is what our function definition. Def my function x, name of the function is my function, x is the formal parameter, and the purpose is what? Square of the x is x square. Suppose here our task is to identify the square. So whatever will be the x, output will be the x square. So if you write my function 5, that means what? Here we need 5 square output. My function 0, that means we need 0 square. Okay. Now we can write, suppose we can execute it. Okay, you can see here. So square of 5 is 25, square of 0 is what? 0. Now can we write here minus 3? You can see the output. So the square of minus 3 is what? It is 9. Similarly, can you write say 119? So square of 19 is what? 361. Okay. So here we are passing the values, numerical values. So my function 19. So that means what is a function call? We are passing 19. So that 19 will go here. So square of the x is what now 19. So 19 square. So 19 square is what? It is 361. Now you can see third example. Here we are passing two parameters. In the previous case, we are passing single parameter. So not necessarily we can pass any number of parameters, but we have to define it. So def add square, name of the function x comma y. These two are the formal parameters. It will return the output x square plus y square. Okay, so it will return x square plus y square. So you can see, so we can call inside the print here, or separately in case 2 separately we just write z equal to something. That means the output will transfer to z and then we just print the z here. So in the first case, add square 5 comma 5. That means what output will be what? 5 square plus 5 square. That means what? 25 plus 25. That is what 50. You can see the output 50. In the second case, add square z. So z will be what? Z will be 2 square plus 9 square. That means 4 plus 81. That is 85. And then we can just print that. Okay, are you getting this one? Okay, now here we are not explicit, we are just passing the value, we are not passing any variable. So we can pass the variable also. We can see the example here in the returning a variable. In this case, this is what our function definition. Okay, add square x comma y, w is equal to, so that means what w is equal to x square plus y square, and we return the value w. So we are returning the w. So in this case also, we just mentioning the two cases, two function call. Here inside the print function and here outside the print function. So z is equal to add square 6 comma 3. So in this case, so that 2 for x, 3 for y. Okay. So z will be what? 2 square plus 3 square. That means 4 plus 9, that is 13. In this case, 6 for x variable, 3 for y variable. So w will be what? Sorry, here w is there. No? So instead of z, you can write w. And here it is z is there. So first initially it is w. W is equal to 6 square plus 3 square. So 36 plus 9. That means 45. And then we transfer w to the z. And then we print the z. Okay. Now, example 5, more than one return value. We can see here in the previous case we just return, in the previous case we return only single value. We return only w. In C also, in C++ we can return only single value. But if you want to in Python, we can return more than one variable. So we can see here add sub mul function. This is the name of the function. That is the function definition. Line number 2 to 6, you can see it's a function definition. Add sub mul function is the name of the function. We are passing two formal parameters x and y. So here my sum x plus y, my sub x minus y, my mul x into y, and we returning three variables my sum, my sub, my mul simultaneously. So here returning more than one variables. So this is what our function call add sub mul function, and we are passing two parameters, two actual parameter 5 and 3. So this 5 is for x variable, 3 is for the y variable. Okay, so the my sum will be what? So my sum will be 5 plus 3, it should be 8. Subtraction of 5 minus 3, it should be 2. Multiplication, it should be 15. 8 to 15. You can see 8, 2 and 15. But we need three variables to receive it. So A sum, B sum, C sum. So first variable is what? My sum. Here we have to define to hold the sum. Second is my sub. We need to define a variable to hold the subtraction. Third one is my mul. We have to define a variable to hold the multiplication, and then we can print it. So we can see the result. So we can see the output. So we can see the output. So x 8, 2 and 15. Now instead of doing this one, we can change it. Suppose now it is 9. Okay, and we can execute it. So 9 plus 3 it is 12. We can see here 9 plus 3 it is 12, 9 minus 3 it is 6, and 9 into 3 it is 27. Okay, and we have to define. So instead of this one, you can write define any variable. We can define m in p also. Okay, so here you can write, we have to write m. Here you can write in, and here you can write p. Okay, and we can run it. We can get the same result. So remember one thing, while define the variable, we should give some sensible name, so that by reading that particular variable, we can guess what is the purpose of this particular variable. So we will just return all the things. Is it okay? Okay. Now we'll talk about types of actual parameters. Types of parameters. Okay. So there are 4 different types of parameters: positional parameters, keyword parameters, default parameters, and variable length parameters. So we will see one by one. So first one is what? Positional parameter. So here correct positional order must be maintained. We have to maintain the position. So we can see here example of the positional parameter, def positional function x comma y. So this is what our formal parameter. So print x to the power y is, so here the task is to print x to the power y. Okay, so this is what function definition, this is what function call. Two function calls are there. Position function 2 comma 3, that means here we need 2 to the power 3. So this 2 is for x variable, this 3 is for y variable. Similarly 3 comma 2, so this is for x and this is for y. So here output will be 3 square. So 2 to the power 3 is what? It is 8, and 3 square is what? It is 9. So the position is important. So if you change the position, we just get the different output. Okay. So you can see the notes on positional parameter. The number of parameters and position of the parameter must be the same. The number of parameters must be same. Here we are receiving two variables. Here I have to define two variables. If the order of the parameters change, the outcome will be changed. Now you can see here it is 2, 3, the output is 8. But if it is 3, 2, the output is 9. We will get an error if we vary the number of parameters. Definitely, we can get the error if you vary the parameters. Suppose here instead of 3 comma 2, just put only one variable for only x variable. There is no variable, there is no value for y. So, and if you execute it, we can get one error message. Okay, so you can see this is what our missing one required positional argument y. So there is no there is no values for y, or if you don't put 3 also, we can get the message, error message, no values for x and y. Are you getting this one? So definitely we have to put the values. Number should be the same. Okay, position should be the same and number should be the same. So this particular part values for x variable, this for y variable, because we have only two formal parameters x and y. We cannot add one more, or we cannot remove one more anymore. And we can see if we execute once again, we can get the correct answer. Next, we can see another example. So this is what our definition. Okay, and here you can see we just already have just seen this one. So if you add one more variable, we can get error message. So here two variables are there, here x and y, so we cannot add one more. Okay, so if you execute it, if you execute it, so it's okay, because 3 plus 2 to the power 3 is 8, and if you add it, you will get error message, because we are passing extra variables. We are passing extra variables. So positional function takes two positional argument, but 3 were given. So we cannot add this one, because it will receive only two variables, x and y, two values x and y. So we cannot add extra. We cannot add any more. We cannot remove any variables. We have to pass exact number of variables, not less, not more. Okay, so just make it. Next, we can discuss about the keyword parameters. So we can pass parameter values by keyword, by parameters name. Okay, so the sequence of those parameters does not matter, but the number of parameters must be equal. Sequences doesn't matter, but the number of parameters must be the same. We cannot add extra, we cannot remove. So you can see the example here. So this is what our function definition. Two parameters are there. So keyword function, name of the function, x and y, two formal parameters are there. The output is print x to the power of y is x to the power y. So this is what the function will return, or it will execute the output x to the power y. So if we pass, so here function callings are there. Keyword function x is equal to 2 and y is equal to 3. So these are the values and these are the parameters. Okay, so here instead of and so x to the power 3 is 2 to the power 3 is what? It is 8. Second time we are calling the same function, but we are explicitly mentioning that y is equal to 3 and x is equal to 2. So it is also what? 2 to the power 3, that is 8. So here we change the position. Same, we can get the same answer. Okay, but we cannot add one more. Suppose we want to add one more, it will give error message. Suppose we want to add one more, you can see here. So we will get error message. Unexpected keyword argument z. Unexpected keyword argument z. We cannot add. We cannot add the extra. We can change the position, but we cannot add, or we may not remove. Okay, suppose here we want to remove this one. Okay, suppose from here we want to remove one keyword and execute it. Then also we can get out error message. Okay, missing one required. Y is there, but X is not there. Okay, so here you can see the position is not important, but number should be number of parameter must be the same. Achha, can you change it? So instead of X and Y, can we change it? So we just execute it. Instead of X and Y, can you write A and B? Can you write A and B? Please execute it. I will upload all this in a GitHub. You just download it and just execute it and tell me whether it will execute or not. Okay, in comment section, tell me whether it will execute or not. Instead of X, Y, if you write A and B. So both positional and keyword parameter can be used at the same time. Remember one thing, we can add both position and keyword parameter can be used at the same time. However, we must take positional parameter first. First, uh, we have to mention the positional parameter. After that, we have followed by keyword parameter. Else, we will get an syntax error. Okay, so you can see here. So we just put this one, so and execute it. Now we can see here function. This is what our function definition. Here the task is x to the power y, and here uh, this particular statement is not required actually. Okay, it's not required. So pk function. So this is what function call our. This is what pk function is the function call 2 comma 3. That means this 2 is for x variable, this 3 is for y variable. pk function another function 2 comma y is equal to 3. So this 2 is for x and explicitly we are mentioning this 3 is for y. Okay, so here we are using either we use positional parameter or we can mix with positional as well as the keyword parameter. So first of all we have to mention the position, then after that we have to mention the keyword. But the reverse is not true. We cannot mention keyword first then position. We cannot do this one. So if you execute it, so you can see the output will be what? Output will be it is 2 to the power 3, that is 8. Here also it is 2 to the power 3, it is also 8. Now if you execute it, now if you execute this one, we will receive the error message. So you can see here, you can see the message, error message. Here the message is what? Positional argument follows keyword argument. Positional argument, this one, argument follows keyword argument. So first we have to define all the position argument, then we can define all the keyword argument. We cannot change the position. Is it okay? So make it and you can execute to clean this. Next we'll discuss about the default parameters. So what is default parameters? So for our positional parameters, we can sometimes assign default values. We may assign some default values. You can see one example. What do you mean by that? So we can delete this one to reduce this one. So just see the this is what our function definition. Default function x is equal to 3 and y is equal to 2. X and y, these two are the formal parameters, and default values are x is equal to 3 and y is equal to 2. And here we are calling the functions so many times. We are not passing any parameters. That means by default it will execute 3 square because the x is equal to 3 and y is equal to 2. We are passing 2 here. That means now we are changing the x value. Now the value of x is what? 2. So output will be what? 2 square. And the default value of there is single parameter is there. That means default value of y is what? It is a 2. If you write 2 comma 3, that means we are changing both the default values. Now the output will be what? 2 comma 3. That means what? It will be the 2 to the power 3. So here x is equal to 2 and y is equal to 3. In this case, we are mentioning the positional parameter as well as the keyword parameter. So this is for x and this is for y. So the output will be 2 to the power 3. So here we are suppressing the default values. These two are the default values here. Default function x is equal to 2, y is equal to 3. So we are mentioning using keyword. Are you getting this one? So if you execute it, we can get the output. So we can get the output. So for first one, 3 to the power 2 is what? It is 9. Second one, default value is what? It is 2. Now it was 3. Now it is 2. 2 to the power 2 is what? It is 4. In this case, 2 and 3 we are changing. So 2 to the power 3 it is what? 8. In this case, first one position, then keyword. In that case, both are keyword. Are you getting? Now, we cannot, definitely, already we know, we cannot mention default keyword first, then position. Just you have seen. If you execute it, we will get error message. Position argument follows keyword argument. Okay, that we cannot do this one. So definitely we can suppress it and we can execute it. Okay. Next, variable length parameters. What is the variable parameter? In variable length parameters, we may provide variable number of parameters. And the asterisk symbol can be used to define the variable length parameter. Now we can see here, suppose here 3 variables are there. Can we add one more? Can we add one more variable? If you execute it, we will get error. Can we add one more? If you execute it, definitely will get error message. So that means what? If we define two variables, so we must give two variables. We cannot put less or more variables. We cannot assign less variable or variable. But if it is required, suppose we don't know how many variables should be there. So if it is required, in that case, we have to use variable and parameter. Okay. So we can see the example of the variable name parameter. This is what our function definition. Line number 229. Variable pf, the name of the function, asterisk n, so that n variable receive as many variables as possible. Okay, the program is very simple. We define one variable, that is mul v, which is initialized with 1, and our task is whatever values are there in n, multiply with that particular mul v. Suppose in n the values are 1, 2, 3, then now mul v will be what? Mul v will be 1, it is already there, 1 into 1, then with 2, with 3. The answer will be 6. Okay, so here we just print the n, here we just print the n, and we print the number of received parameters. It is len n, and we print it. Okay, so we can remove this in also, and we can run it. So we can see here variable, we are calling the function 2354. So we are passing 2354 in n. So n will hold 2354. So mul v is what? It is 1. So mul v, you can see here, mul v is equal to, initially it is what? Is 1. So received n is what? 2354. 2354. Number of parameters, length n, length is n is what? It is 4. 4 parameters are there, 1, 2, 3, 4. And here we use one loop to multiply the values present in this particular n. So the output will be 1 into 2 into 3 into 5 into 4 using this loop. So definitely output will be what? 120. Okay. Now here, okay, here how many parameters are there? Four actual parameters are there. Now can we change it? Yes. Now if only 2 parameters there, so this is what output. Okay, so instead of 2, can you change it 4? Yeah, it's okay, no issue. Now can we put the single, say it is a 10? Yeah, we can do it. Now is it okay not to pass any parameter? Not to pass any parameter, is it okay? Run it. Yeah, it is also okay, no issue. Okay, so this is what variable length parameter. We may pass parameter or we may not, and that the numbers is not fixed. We may pass as many number of parameters. Okay, so we can add it. Suppose here we 6, 7, 8, 9, 10, 19. Can we do this one? Can we execute it? Yeah, it's okay. How many parameters are there? 10 parameters are there. It's okay. We can pass it. And the value is what? This one. Okay. Acha. Can you write here range 10? Can you put here range 10? So please do it yourself, and in the comment section you tell me the answer. Is it okay? If it is it okay? Is it possible to mention range n inside it? And if it is possible, what is the result? So we have to play with the programs. Otherwise, it's not we cannot learn. We cannot learn the programming language properly. We have to play with this. Okay. Okay. Now mixing variable and parameter with positional parameter. So here we are using positional as well as variable length together. So we just see this one. This is what our function definition, line number 2 to line number 9. So the name is what? Variable pf, name of the variable function. We are passing two parameter, data and asterisk n. Data is the what? Is the positional parameter, and n is what? Variable length parameter. And we initialize mul v using the data, using this particular data. So mul v is equal to data. Okay, and here the task is to data in is means we have to print the n. Then we need to print the n. So here no need to mention the new line. And here we add one for loop to multiply the data present in this particular n. Suppose here 3, 4 is there. If n contains 3, 4, the output will be what? So this 3 will be the data, and 4 will be the n content 4. Similarly, in this case, 2 will contain the data will store 2, and n will store 4 and 5. N will store 4 and 5. Okay, so we can execute it and we can see the result. So here, just okay. So you can see this one. Here variable pf 2 is there, so this 2 is for the data. So 2 is data, and n holds nothing because no data left for the n. Okay, so the multiplication is what? 2. Only definitely only 2 is there because in mul v we just pass the data. Okay, now instead of doing this one, if we enable this particular, so the data will be what? Now if you change it, now it is 3, and if you execute it, we can see here, the data is 3. This is for the data, and n should hold 4 and 5. So data is 3 and n hold 4 and 5, and definitely output will work. 3 into 4 into 5, that is 60. Is it okay? So we can change. So one more thing, suppose here we can use the keyword parameter also. So we suppose data is equal to 5. If you mention data is equal to 5, can you do this one? Just execute it. No, we cannot do this one. So we cannot do like this way. So this is for in and this is for data. We cannot do this one. Okay. Now the question is, can you put data first? So can you write data is equal to 2, and this is for, can you execute it? Okay, we cannot execute this one. We cannot mention both. Are you getting this one? So we cannot do this one. So you can check it. You can check different scenario. So here we can add as many variable. So if we execute it, So here we can see first we look for the data 3, the remaining 4, 5, 8, 9, 10, 4, 5, 8, 9, 10 for the n, and definitely if you multiply 3 into 4 into 5 into 8 into 9 into 10, it is 43200. Okay, so this is the example of mixing variable length, means positional as well as variable length. This is what mixing with variable length with the default value. So variable length with the default values. So we can see here function definition. This is what our function definition, line number 2 to 8. Function callings are there. Here function callings are there. The name of the variable is variable pf. N is what? Variable length. Data 1, it's a default value. So data 1 default value is what? It is 1. So mul v, so definitely data should be what? If you pass or we may not, the mul v always should be the 1. If you pass it, it's okay. If you do not pass it, mul v should be 1. Here we are printing the data is this one and n is this one, and we are multiply. Here we just multiply the data present in this n. Okay, capital N, and we just print it. Here we just print it. So we can execute it and we can see the result. So if you execute it, we can see. So here we can see here n data is 1, default value is what? 1, and these two n holds the 2, these two. So the multiplication is 1 into 2, definitely it should be 2. Is it okay? We can check this one. This one you can check and we can execute it. We can see here default value is always it is 1. If you unless we just change it, the 245 n holds all 245, and definitely 1 into 2 into 4 into 5 should be what? It is 40. So if you want to change it, explicitly we have to mention it. Okay, so if you want to change it, so what you can do, you can execute it. You can execute it and you can see the result. You can see the result. Here the data contains 5 and n holds 2 and 4. So 5 into 2 into 4, it is also 40. Okay. Acha. Can you change the position? Can you change the position? Can you write like this way? Can you write like this way? First data, then the global variable, then the variable, say 4, 5, 7. No, it is not okay. Positional parameter follows keyword arguments. Okay, so we cannot do this one. So definitely we cannot do this one. You can save it and now keyword variable length parameters. Now we'll see keyword variable length parameter. In that case we use double asterisk, and internally these keywords are stored in dictionary format. Dictionary format already you know. It is what? In key value pair. It should be in key value pair. Okay, we just see the one. So we just see the program. Function definition, line number 2 to 4, name of the function, and we are passing double asterisk kw arguments. That means keyword arguments. So it will stay in dictionary format. So here we iterate as dictionary. Suppose you already know how to iterate the dictionary for key value in kwargs dot item. Okay, so it will print the key as well as value. Okay, now we are calling the same function 3 times. So first time we can see here, we just see one by one. So suppress it. Here how many keyword is there? Single keyword is there. So if you execute, what will output? The output is what? It is pi 3.14. Now, can you change number of keyword? Yes, we can change it. Say name Kapil, address Chandigarh. We can execute it. Now you can see name Kapil, address Chandigarh. Can we change it further? Yes, we can change it. So here A is equal to 1, B is equal to 9, C is equal to 7. We can change it. So you can see the output. So this is what variable and keyword parameters. So when you mention this one KWARGS store in key value pair A1 B9 C7. Okay. Acha. Instead of KW, can you change the name? Can you write capital A instead of this one? Can we execute it? Yes, we can execute it. Not necessary to put KWARGS. You may mention whatever you want. Is it okay? Next, put all together. The use positional variable length as well as variable keyword all together. So you can see the function definition. Line number 2 to 11 function definition is there. This is name of the function. A and B positional parameter, variable length parameter, variable keyword parameter. It's a simple program. Here we just print A and B value. Okay. And here in this case, we just add those values which are present in this one. And in this particular part, we just present the key values present in this key value pair present in this particular variable keyword. Are you getting this one? So we just print the AB value, and for asterisk ARGS, for this ARGS, we just store sum the values present in ARGS, and we just display the content of KWARGS. So AAB is for positional, asterisk ARGS for variable length parameter, asterisk KWARGS for variable length keyword parameter. Okay, and we can execute it. So if you execute it, so you can see this one. So name of that function 2 3, A for 2, 2 for A, 3 for B. This is for the ARGS, and this was for asterisk or KWARGS variable. So we can execute it, and you can see. Okay, see 2 and 3, here B is what? 2 and 3. If you add this one, 10 plus 11 plus 12, that is what? 33. Great goal. Great goal. So X holds the great, Y holds the goal. So that is nothing but what? It should be, it is in KWARGS variable. So we can increase the this value. Now, are you getting this one? So we can say you can change it. So now if you change it, you can see here this is for A, this is for B, this is for ARGS, and this is for KWARGS. Okay, and you can run it. Definitely you can get the result. Okay, next, difference between function, module, and library. So what is function? Set of lines saved with name is called a function. So this is what function. So what is module? Module consists of set of function. Module consists of set of functions. Suppose three functions are there. So together we call it is a module. Library consists of set of modules. So different types of different modules are there. Here also functions are there. Say F4, F5, F6, F7. Together, it is called library. So set of lines saved within the same called function. A module consists of set of function. A library consists of set of modules. Okay. So we can draw simple small. So F1, F2, F3, it is called module 1. F4, F5, F6, we can say it is a module 2. Together, we can say it's a library. Next, types of variables. There are two types of variable, global variables and local variables. So what is global variables? Global variables are variables that are defined outside of a function, and all functions in that module can access in these variables. Suppose function 1 is there, another function 2 is there, but one variable a is defined 6. So function 1 as well as functions 2 both can access this global variable 6. So this is what? It's a global variable. Similarly, suppose a is equal to 6, and if one here we mention b is equal to 3, another function is there. So this one is the global variable, but this one is the local variables. B is equal to 3, only this particular function can use it. If 2 cannot access this b3, if 2 can't access this b variable, if 2 can access a and b, a only. If 1 can access both a and b. Okay, so these are the global variable, this one is the local variable. Okay, and it is defined outside. In global, it's defined outside the function. We can see the example. So we can see the example here. Pi is equal to 3.14, it's a global variable. We define two functions, global variable function 1 and 2, and we are using this pi variable. Okay, and we are calling these two functions. Definitely we can get the answer. The value of pi in f1 is this one, the value of pi in f2 is this one, because we mentioned this one as a global variable. Okay, so we can see here, we can execute it, we can get the output. Now, so notes on local variable. Local variables are variables that are declared within a function. Okay, these are only available in the function where they were declared. We cannot access it from outside the function. We cannot access it outside the function. So we can see here, we can see one example. Suppose here a is equal to 10, it's a global variable. One function is there, b function 1, here a is equal to 20. This is nothing but our local variable. Another function, v function 2, here we use this a. So here the output will be the 20, because local variable suppresses the global variable. Here the output should be the 10, because that particular v function 2, it will use the values of the global variable, and we can execute it. We can see the result. So we can see the result. So this one is what, 20 as mentioned, and this one is the 10 as mentioned. Okay. Now explicitly we can define the global keyword. A is equal to 10, it's a global variable. Def v function 1, and function 2. In function 1 we mention global a. That means what? Now we define this a is nothing but the global. It is not a local. Okay, so if you print this a, the output will be what, 20. And here also, if you print a, the output will be 20. Because we define this a is a global and we will modify the content of a, the output should be the 20. We can see here. So f1 print, for f1 the value is what, 20. For f1 it is 20. For f2 the output is also 20. For f2 output is 20. and we can execute it, and we can see the result. Now if you suppress it, if you remove it, here the output will be the 10. Instead of 20, it should be the 10. So you can see here now it's what? It's a 10. Is it okay? Now if you rerun it and define it, now it will be the 20. Next, accessing global variable and suppressing local variables. Now we can see it's a global variable. Okay, one function definition is there, function 1 is there, here function 2 is there, and a is equal to 20, it's a local variable. Now if you print a, simple a, it will print 20. If you print globals, then bracket, then a, it will print the 30. So it's suppressing the local values. It will print the global a value. So to print the global a value inside the function, we have to put this particular syntax. And if you execute in function 2, a, definitely it will use the 30. So we can see first a output will be what? 20. Second a, we are using the global 30. And third, definitely it should be the 30. Okay. Now we can do this one. We can execute it. I can get the result. So instead of 30, if you write 50, we can get according to that. We can get the result according to that. Okay. Next, we can see another example. Say this is what our local variable. Okay. This is what our, sorry, this is what our global variable. This is what our local variable. Print the local variable. Now we can see the chronology. This is what our function definition. First of all, we define the var1. So definitely it will print 10, this one. Then we call the local, that function. So it will print 20 for this one. Once again, we call the global variable outside the function. Outside the function, it should be the 10. So the output will be what? 10, 20, 10. 10, 20, 10. Okay, we can change it and we can execute it. We can say you can execute it. Or suppose instead of 20, say it is 50. So you can see the result out. You can change, see the change accordingly. 10, 50, 10. Few more examples on local and global. You just see this one, this function. This is what our global variable. This is what our function definition. And here we print the variable. So first of all, this is function definition. First of all, we print the variable var. So the output will be what? It is 1. Next, we increment the var value. The var should be what? Should be 2. Next, we call the function. So the call the function is my function, and we define global var. This var is a global, and we increase this one, increment this one. So it should be what? It should be 3. So here print this var, so it should be 3. So we just print this one and this one. So output will be what? 1 and 3. Okay. So we can see it. It's 1 and 3. Okay. So instead of 1, if it is 11, we can see the change of accordingly 11 and 30. Okay. Next, see another example. So it's a global variable. Now there's a function. Inside that function, we define another variable, variable 13. So it's a global variable. It's a global variable for my function 1. Where 13, it's a local for my f1, but global for my f2. It's another function. It's a nested function inside the function. And here we print the var. So what do you think? It will print what? 10 or 30? Definitely, it will print 30. So it will print the just global. So the variable defining the parent. So because f1 is the parent function of f2. So whatever the variable present in the parent, f2 will receive first. It will receive the parent variable, which is defined as a global. So for my f2, that 13 is a global, but my f1 10 is the global. Okay, so we can run it and we can see the output. So definitely it is a 13. So we can add as many times as possible. Suppose here we want to add this one. So the output will be what? 13 and 10, 13 and 10. Okay. Question is forward reference okay? Now here we define the function my f1, and we define another function my f2, and where you call my f2 before that definition. So it's called forward reference. So if you call my f1, so first it will call this one, then it will value will be 10, then it call my f2, and here we pass the val, and it will print the value val. So before definition of the function, we can call it, we can refer it. Okay, it's okay, no issue. That we can do it. And the definition is about 10. So instead of 10, if it is 30, the output will be what? 30. Next, we can see it's a very interesting one, the non-local keyword. We can see here. It is used to work with variables inside nested functions that shouldn't be part of inner function. Okay, we just see the example first. Okay, so see the function first. So function 1, this is what our function 1. This is what our function 2. Okay, now here data is equal to 5. We define data is equal to 5 as a global variable. Assume it's a global variable. Okay, so data, it is defined as a 5. Then we define global data. It's a global data 10. So here it's a local value. So now it is 10, and we just print it. And in my function 2, we define another variable data. It's a now set 20. Okay, and we print the data. My function 2, we just call this particular function, and we print the data 3, and we just return the data. And first function calling is what? My function 1. So my function 1, it will call this particular function. So first it will print this one, data 1. So the data here, the output will be what? Output will be 10. Okay, because it's a local variable. Now second data is what? Now second is what? Second call is this one. Here we define this one. So here data 20 is what? It will print the 20 because of this 20. After that, end of this particular function, then print data 3. So it will print that data. Okay, so 10. Next, it will print data 3 is over. Then it will return some value to that particular, and it will print that data. Here the data should be what? That data, that is 10. And finally, print data 5. Here we just print this particular data, and which is we can say, if we execute it, it should not be 20, it should be 5. Now execute it. So we can see once again. First of all, you just see the function 1. Next, function 2, function 1 calling here, function 2 calling here. So first function call, my function 1. So it will jump to here. Here the data is what? 10. It will print 10. Then data 1 is 10. Next function call this one. It will jump here. The data is 20, and it will define data 2. it should be 20, no issue. Next print is for data 3. It will print this data. It's a global local variable for my function 1. Then this my function will return this data. This data is nothing but a 10. It will print 10. And data 5, it is just this data, nothing but this one. That's why it is 5. So if this is the situation, it will be what 10, 20, 10, 10, 5. Now we just change it. Instead of here, uh, you just put global. Okay, and execute it. Then what will happen? You can see the changes. So instead of 5, so 10, you can see once again. So first function call my function 1. So it will print, you just remove it. You just remove it. You just remove it. So first function call my function 1. So in my function 1, now it's a function 1, data is a global, data is equal to 10. So this should be the output would be the 10. Next is what my function 2 call is there. And here the data is 20. It's a local variable. Output will be 20. Then it's a data, print data 3 data, data 3 data. It should be print 10 because it's a 10. Now it will return data 4. It will return receives the variable. It will receive the variable data, which is a 10. And finally it's a data. Now it will change it to global. So definitely that's why it is 10. So here in this case, the output is what? 10, 20, 10, 10, 10. Next, what you can do, we just change it. Now it is a suppress it and we put it as a global. Okay, and execute it and see the differences. Is there any differences there or not in output? Now see the changes. Function call my function 1. This one, data is equal to 10, print data. So the data will be what? 10. Next function call this one and we define as global data 20. Okay, and print the data 20. So it will be 20. Okay, then it will print the data 3. Data 3, that data. So that data is what? That data will be what? Will it change to 10 or 20? Okay, so we can see the data is still it is a 10. Data 3 is still 10. So the data 3 is nothing but this. Data 4, it will receive the return the data which is a 10. But now the global, the outermost variable, now it is not 5, it is 20. So here you can see 10, 20, 10, 10, 20. Is it okay? Because so we have to mention local, global very carefully. Others will get different answer for different cases. Now, if you define it's a non-local, then what will happen? And if you execute it, now you can see the differences. Now it is 10, 20, 20, 25. 10, 20, 20, 25. Now it's just different set of output. Nothing is no. You can just see the set and that set is not present here. Just different set of output. Now see the. So data first function call is this one. So first print this one, this data, which is a 10. No problem. Then we define non-local data. And we define data is equal to 20. Now it will change that data to 20. Data 2 is what? Data 2 is 20. Now simultaneously it will change the the content of this data also. Now it is not 10, now it is 20. Okay, and content of the D3 also. Now it is also 20. and it will return the data 4 also contain the 20. Is it okay? Because data 3 is nothing but what? Data 3 is nothing but that 20, so it will return data 4 also 20, but the data is not 20, now it's 5. So that means if you put non-local here, we just change the parents variable. So the parent of this variable is what? Parent of my function is function 1. It will change this content of this. Okay, it will not change the outermost global variable, this particular variable. So please download this particular program. You just change global to local, local to global, and see the differences. Then you can understand. Okay. Now we can remove some variable. Okay. So you just see if we define non-local. If you define the non-local, the output is what? Keep as it is. The output is what? If you define non-local, output is what? 10, 20, 20, 25. If you define it as a global instead of non-local, then what will happen? See the difference? It is 10, 20, 10, 10, 20. 10, 20, 10, 10, 20. If you define as a global data. If you remove both non-local as well as global and run it, you can see the output 10, 20, 10, 10, 5. 10, 20, 10, 10, 5. So we suppress all. Initially, data is equal to what? 5. Okay, global variable. Now local variable data it's set 10. So it will print what? It will print 10 and it will return data 10 and data 3 is what? That is what global variable 5. No problem. So it is a 10, 10, 5. If we remove, if you use non-local, if you use global data, okay, and you just execute it. So the output is what? The output is 10, 10, 10. So first function is what? Data 1, it is a 10. Next is what? It will return the 10 to the data 2. So that's why it is 10. So 10, 10, and global data it will change to 5. Now it will be 10. Now instead of doing this one, if it is a non-local, then can you see the changes? So we cannot, no binding for non-local data. So we cannot do this one. So we can use non-local inside the function of a function. So if it is a nested function, then only we can use the non-local data. Okay. So we cannot do this one. If you once again execute it, no, it's okay, no issue. So if it is inside the function of another function, then and only we can define non-local. But if it is a simple case, in that simple case, we cannot use non-local data. So you can check the things. Okay. So you can see this particular program properly and you can see it. Okay, so it's a global data and do this. So can we put both the non-local and global? Can you execute it? No, it will not. The data is non-local and global, so it is not okay. We cannot use both. You can use any one of that, not both. Next, recursive function. Function call itself for specified time. So you can see the recursion. So function call itself. So this is what function definition. Name of the function is factorial. If n is equal to 2, return 1, else return n into factorial. So we are calling the same function with reduced parameter value. So we just call the factorial 4. Factorial 4 is 24. Factorial 5 is what? 128. So in recursive function, two parts are there. This is called the base case, and this is the recursive case. So base case, a program doesn't call itself in base case, and in recursive case, a function call itself. So for recursion, base case must be there. So if base case is not there, so it will execute infinite time.
Okay, see another example of non-local. We just see the function once again. So this is what our my function 1. Then here we define the data 10. Then my function 2. Okay, inside my function 2 we have defined another function, my function 3. Okay, and here we call my function 1. Here we call my function 3. And here we call my function 2. So we call my function 2 inside my function 1. We call my function 3 inside my function 2. Okay. Now here we defined non-local here. So if we define non-local here, and we need to see the changes. So first time it is where you call the my function 1. So the data is 10. So here the output should be the 10. So data 1 should be the 10, no problem. Then non-local data, here it is defined. So data is equal to 20, the print data. So here it should be the 20, no problem. Now here function 3 is there, the data is equal to 30. Here the output should be what? It is 30, no problem. Now here it is data 5. So data 5 is inside function 2. It is inside function 2, and here it is defined as 20. So that's why it is 20, no issue. It is no issue, no problem. Here it should be the 20. Now data 6 is defined under my function 1. So here data 6, it is defined as 10. It is defined as 10. But here the output is data 6 is 20. The output is 20. So non-local data, it modifies its parent's data. So non-legal data, it modifies parent functions data. So parent function is my function. So for my function 2, my function 1 is the parent function. So here the data is what? 20. Now it is, now initially it is 10, now it is 20. And here we are passing this data which is 20. So we are returning the data 20. So that's why our data 7 is also should be the 20. Now the conclusion is what? Non-local data, it modify its parent, but it doesn't modify its child function. So here as it is 30, it is not 20. Okay. Now if we so we may write down this one. So if it is there, so the if it is non-local is there, so the output is what? 10, 20, 30. Okay, 20, 20, 20. Then suppose we don't want the non-local variable. We want this non-local, and we want to change. We want to see the changes. If it is the case, then we can see the different output. So here it is data 1 is 10, no problem. Now data 2 is 20, no issue. Data 3 is 30, no issue. Now data 5, you can see now it is 20, no issue because it is 20, no issue. Data 6, now it is 10, it is not 20. And we are returning this 10, now it is not 20, it is 10. So that means what? Here we do not use non-local data. So that's why it didn't change its parent variable data. And definitely we are returning this 10, that's why it is 10. So here, if you do not use non-local, the output is what? 10, 20, 30, 20, 10 and 10. Now, suppose we want to change, this one. We want to change non-local here. Suppose here we define non-local here inside the my function 3 non-local data. Okay, and execute it. Now we can see here we can see, so it is 10. So here output is what? It is 10, no problem. Now here it is 20, data 2 is 20, no problem. Now data 3, it should be 30, no problem. Now data 5, it is inside the my function 2. Here data is defined as 20, but it is printed 30. Okay, so that means 30. Okay, now and here data 6 is what? Data 6 is inside the my function 1. It is my function 1. Here it is 10 is there, so that's why it is 10, and we are returning this data 10, so that's why data 7 is also 10. Now we can see one conclusion. We can see that if we apply non-local data, it will change only its parent's data type, data value. It doesn't change its parent's data, or it will not change all the values. Okay, so non-local data, its parent data is what? This one is parent data. Now instead of 20, it is 30. But still that data is 10. Still that data is 10. Okay, so if we want to change, the conclusion, if we want to change its parent variable value, then in that case we have to apply non-local data. Okay, so please download this particular program and modify it. Now instead of non-local here, you just write down global data here, or you put global data here, then you can see the changes.
Next is anonymous function or the lambda function. It's a very interesting concept. Sometimes we declare a function without giving it a name. These functions are known as anonymous function or lambda function. Okay, so we use lambda keyword to define the lambda function. So here we put lambda, then argument list and the expression. So lambda x is the argument list and the expression is what? X to the power x, or x into x, sorry, it is x into x. So in this way define a lambda. You can see the example. In this example, my f, name of the function, lambda. Okay, syntax we have to write lambda. Then this is what our argument list, parameter list n, and it is what? N into n. And we can use that particular function using myf function name. So myf is the function, and we have to pass parameter 4. So this is nothing but the n value. In the second case, this is our n value. Okay, and we can execute it. We can get the result. Okay, you can get the result. So instead of can we put it, can we pass two parameters 4 and 5? Can we pass two parameters? No, you cannot pass two parameters. It will receive only one parameter, so it will print the error message. Now to do the same function, to do the same thing, what we can do? We can write like this way: def myif in return in into in. So this one and this one both are same thing. Okay, so using this short way we can represent the function. So my f is the name of the function, n is the parameter, and this is the expression. So not only single argument, single parameter, we can pass more than one parameter also. We can see this particular example: my lambda a comma b, two parameters are there. The task is a to the power b. So 2 to the power 4, the output will be what? 16. 3 square, 3 comma 2. So this 3 for a, this 2 for b. So 3 square means what? It is a 9. Okay. Now we can use lambda inside the another function. So we can see here, my function is there. In my functions, we define another lambda function. So result is equal to lambda in colon x to the power n. So x is what? It is a 4, and here we pass the n. So if you call the function myfunc, func, myfuncs, that means what? Value will hold the result. Result is nothing but this lambda. And if you put value within bracket 2, that 2 is nothing but this, for this 2 n. And the value of x is 4, what? It is already 4. So 4 to the power square. So that is what? It is a 16. So we can change it. So here, instead of 2, if you put 3 here, you can get the result 4 to the power 3. So it is 64. Okay. Next, we can append lambda. Okay, we can append lambda in it. We just see it's our function definition, myfunc. A data is a list. In data, we I in range 10, data append lambda. So here we put the lambda. So for lambda say 0, if I is equal to 0, lambda 1, lambda 0, then lambda 1, then lambda 2 till lambda 9. So when it is lambda 0, that means what? The I is what? I is equal to 0, and whatever is the x we just pass. So execution will be I to the power x. So 0 to the power x. Here it should be what? I is equal to 1. So 1 to the power x, that means what? It is 1 to the power x. In this case, it is 2 to the power x and so on. It is 9 to the power x. So here we call the function my function. So it will return value hold the data. Okay. And we pass value 2. Value 2 means what? We are mentioning this one. And here value 2. 2 means what? It is I is equal to what? I is equal to our 2. Okay. I is equal to 2. And the value of x is what? It is 0. So 2 to the power 0 is what? 2 to the power 0 is what? It is 1. So we can execute it. Now if you put, it is say 3, 4. So what is I here? I is equal to 2. So 2 to the power 4. 2 to the power 4 is what? So it's a 16. Now if it is a say 1. So that means a 1 to the power 4 should be what? Always it is 1. Okay. Now if it is 0, if you pass 0 here, that means the value of x is what? 0. 1 to the power 0 is what? It is 1. Now if it is a 5 is there, 5 to the power 0, always it should be 1. Okay. So that value, this is for value 0. This is for value 1. Okay, not this one, this one. And for value 2, this is for value 2. This is for value 1. This is for value 2. So if you put value 2, if you put value 2 here, that means 2 to the power something. 2 to the power, suppose 2 to the power 10. So the output will be what? It is 1024. Okay. So we may build very brief code with Lambda function. Definitely, it improves the readability because we can reduce the number of lines. No explicitly return statement is required. Okay. Using Lambda function, we can pass functions as argument to another functions. So definitely we can pass functions as another functions. Explicitly, return value is not there. Now more examples of Lambda in list. So my list. So we can see this is a my list. So this is what? 0th, 1, 2, 3. In 0, we just increment the value. In 1, we just decrement the value. In 2, square root. In 3, square. So f in my list. So if you put f3, so that means what? Increment value of 3, decrement value of 3, square root of 3, and square of 3. Okay. So for f in my list, so the values of f. So f in list, my list means what? So for if for f, we just passing the 3 is nothing but the x value. So if the x is 3, so in the first time it will increment, second time it will decrement, third time square root, fourth time square. Or directly we can use my list. We can write like this, my list. So my list 3 comma 3. 3 means what? So 3 will be what? 3 will be this one. So 3 square is what? It is 9. So in this way also you can change it. Now if you put say 5, so the value of x will be what? The value of x will be 5. Okay, and if you put here 2, if you put here 2, 2 means what? 2 means square root. Square root of 5 is what? Square root of, we just executed. Square root of 5 is what? 2.23. Okay. So more example of lambda in dictionary. So my list, here we can define as inside the dictionary. So for increment key, value is this one. For decrement key, value is this one. For square root, the value is this one. We can call the my list and we can execute it one by one. So my list if, so for each and every key, it will return the addition, increment of 4, decrement of 4, and square root of 4. So increment of 4 is what? 5, decrement 4 is what? 3, and square root of 4 is what? 2. Okay, so the value of inc is what? If you just print the f. So already you know the dictionary iteration. Next, lambda with filter. So the filter function is used to filter values based on some conditions from the given sequence. So syntax is what? Filter, right? Filter, we have to pass function and the sequence. And it will return the values from the sequence if the condition is true, if it satisfies the function. So we can see here lambda with filter, the data is nothing but range 10. So data will hold say 1, 0, 1, 2, 2, 9, and function 1 and function 2 are there. So list filter is just filter. Okay, filter is there. Function, this is what our function, and the sequence, that is the data. So it will check the data one by one. If it is even number, it will pass it. In this case, it will check the condition. If the value of x is greater than or equal to 5, then it will pass it. So you can see the result. So for this one, the output is 02468. And for this one, you can see the value, these are the values which are greater than or equal to 5. So 5, 6, 7, 8, 9. So in this way, we can apply filter function with the lambda. So filter, function, and the data. Now we can see lambda with map function. For every data present in the given sequence, apply some functionality and generate new data sets with the required modification. The map, you just syntax map, we have to pass the function and the sequence. Data is equal to 5, range 5. That means data is equal to what? 0, 1, 2, 3, 4. And here is the function. We pass the function. Function is what? Whatever may the data present in, you just square it. So it will iterate the data one by one, take the data one by one, and it will square it. So 0 square is what? 0. 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, and so on. Okay, so we can execute it and we can see it. So if it is instead of 5, it is a say 17, you can see the result. Okay, so you can see the difference. In this case, we just check the condition. And in this case, we apply the function for all the data present in data. So if you change the condition, so instead of this one, if you put not, so it will print what? The odd values, print the odd values. It will change the output. Okay, now it will print the even values. So these two are very important, very useful. Filter and the map. We can see another. So instead of, so we can apply the not only single data set. We can use two data sets, so data 1 and data 2. So data 1 is what? Range 5. So data 1 hold 0, 1, 2, 3, 4, and data 2 holds 6 to 10. So 6, 7, 8, and 9. Okay, and map, the function is what? X and Y. So data will provide data for X, data 2 will provide data for Y. So x to the power y, that means what? 6 to the power 0. Data 1 is what? X to the power y, that means what? We can say 0 to the power 6, 1 to the power 7, 2 to the power 8, 3 to the power 9, and 4 to the power. Nothing is there, it will not print anything. So 2 to the power 8 is what? 256. 3 to the power 9 is what? 193. We can execute, we can result. Now instead of, if you put 11, so 11 it will print what? It will print 4 to the power 10. So 40 to the power 10 is what? So 0, 1, 2, 3, 4, 6, 7, 8, 9, 10. 4 to the power 10. Okay, and you can execute it, we can result, you can see the result. 4 to the power 10 is what? 1048576. Okay. Achha, instead of 12, can you write 15, 15 here? Can you execute it? Yeah, you can execute it. It depends upon the, can you change it? Yeah, I can change it. So no issues there. Now lambda with reduce function, it reduces the sequence of elements inside a single element by applying some function. So the syntax is what? Reduce. Okay, and we have to pass the function and the sequence. And here we have to import func tools. And then and only we can apply the reduce function. Here the reduce will receive the data and it will add it. We can and you can get it the sum of that single value. Okay, so data is 2463. So if we add 2 plus 4 plus 6 plus 3, the output will be what? It is 15. Okay, now make it simple. Suppose here it is say 1 and here it is say 4. Can you multiply it? Suppose if you have a multiply, then what will be the output? So 2 into 1 into 4 into 3. So it is 24. Can you apply division? Can you apply division? So please check it. Please check it and tell me the answer, whether it is possible or not. If it is possible, what is the result? Is it okay? Function aliasing, that is renaming a function. Okay, renaming a function. We can see here. You just see the so this is what function definition. Add my. So it just add x plus y. This is what function calling. Okay, and here you print the ID of that function. Okay, and here renaming this one. So add my sumMy is nothing but same as addMy. And we can use both sumMy as well as addMy. Okay, so we can use both sumMy as well as the addMy. So we can use both sumMy as well as addMy. So sumMy is what? Sum 6 plus 2 is what? It is 8. And 4 plus 5, it is 9. So here sumMy is 2 comma 6. In this case, addMy 2 comma 6 also you can change it. Say 10 comma 12. We can apply. So it should be 22. Now, if we delete a function, we still can access that function using Aliasing. Suppose we delete the addMy, tillMy, and uh, if you delete this one, question is, can you use this one, sumMy? So now it is, say, assume it is 3 comma 6. Okay, and no, 60 answer. Okay, it's okay. Means we have deleted the addMy, we have deleted this addMy, but still we are using sumMy. Is it okay? We can use it. So del addMy means what? We are deleting that particular function. Now suppose, now after deleting, can you use it? Okay, after deleting we cannot use it. AddMy is not defined. Okay, so in this way also you can delete the function. Nested function. Declare a function inside the another function. It's called nested function. So already we have seen. So this is what our outer function. Insert function, we define the function inner function, and we call the inner function inside the outer function. So if you call outer function, so it will execute this one. So first it will execute this line, then print, then execute this particular line, then call the inner function with this one, then execute this one. So 1 2 3 sequence will be 1 2 3. So 1 2 3. So we can execute it, we can see the result. Okay, so this is called the nested function, function within a function. This is the nested function, and we call this particular function here. Here we are calling the function. Function are first class objects. It's a very, very important concept. You can see here, everything in Python is viewed as an object. We'll see in object details in the later video. In Python, functions are first class object since they can refer to, pass to variables and return from other functions. So that means what? We can pass functions, we can return functions. The functions can also be called or supplied as variable and returned from other variable. Functions can be called, supplied as variable, and returned as other function. The functions can be declared inside another function and supplied to it as an argument. That means suppose one function is there, defined function. Here we can pass as argument also. We can return the functions also. So this is f1, this is f2, this is f3. So we can pass as a parameter, we can return as parameter. Now passing function as argument to another function. Okay, so we can see here, this is what our function definition, my square x. So the task is to execute x square. Result is equal to list my map my square. So my square is nothing but the function we are passing this particular function. Already you have seen the map, and the data holds 1 2 3. So all the elements present in the data will pass the my square, and it will execute 1 square 2 square 3 square, that is 149, and we'll print the result here. We just print the result here. Okay, so here we are passing function as parameter. Okay, so we can execute it and we can see the result. You can see the result. Now we can put as many variables and can execute it. So 5 square is 25, 3 square is 36. So here we are passing a function as argument. Next we can see function can return another function. Now we can see this is what our function, outer header. Inside outer header there is a inner function, inner header, and the task is to add uh, add something and return. It will return, and outer function return the inner header. Inner header is nothing but the functions. So here returning inner header as argument, we are returning the function. So function can return another function. So outer function, you just see this is what our outer function. In outer function, we just define the inner function and use the inner function. Here the parameter is x, and for inner order it is y. So adding values outer adder 5. So 5 is nothing but is what? The parameter for x. So x is equal to what? It is 5. Okay. So adding values is nothing but what? Adding values is what? We just hold in adding value, we just hold the inner adder with the value of x 5. So in adding values, here this one is adding value, we just hold the inner adder, which is nothing but this particular function where the value of x is 5. Now if you execute this particular, if you call this adding values and we pass parameter this 10 is nothing but the value of y, and it will return, that particular function will return x plus y, that is 15. Is it okay? Is it okay? Just see once again. This is what our outer adder function. We just define another function, inner adder. Here we are returning x plus y. This particular function returning x plus y, and this particular function is returning the inner adder as argument. If you call outer adder 5, that means this one, and it 5 is for the value of x. So it will return the inner adder to the adding values. So adding value holds what? Inner adder with the value of x is equal to what? 5. Whenever we execute the inner adder, adding values, the inner adder with 10, that means what? We are executing this inner function. So where the value of x, already of value of x is 5, and we are passing 10. That 10 is for the variable what? Y, and that particular function will return x plus y. So 5 plus 10, so it will return what? So it will return 15. Now we can add one more. You can see one more time, and we just change the value. Instead of 15, if it is say 13. Okay, so what will be the output? So we just some in values are here. Can change it. Can change it and we can execute it. So you can see here the value of x is what? 5. The value of y is what? 10 for this 10. So that's why 5 plus 10 is 15. Second time the value of y is what? 13. So 5 plus 10 reverse, it is 18. So here the value of x is fixed. The value of x is fixed. We just only change the y values. So please download this particular video from the GitHub and you just check it. Okay, you can print this one also. If you want to print, you can print this one value and you can see what is there. So actually still I didn't explain the object, that's why I just ignored this particular part. Okay, so function returning another function. So that function is there. it will return this particular function which is defined here. If you call this particular function by passing parameter, where passing parameter for x, it will return the inner adder to the variable adding values. And whenever you call it and pass some parameter, where pass parameter for another example. Now we can see there is one outer function. Okay. Now here even function is defined, odd function is defined, and it depends upon the condition. It will return even or odd. Okay. Now test is equal to outer function. Suppose we have passed outer function, that means we are passing this one. So and we are passing 10. So 10 is what? Number is what? 10. So 10 is what? It's a even number. So it will return even, this particular function. And whenever you call test, it will execute this one event, and it will, the number is an even number. The 10 is an even number. In second example, suppose outer f13. That means we are passing 13 as a number and it's an odd number. That means it will return odd. It will return this particular function. And whenever you execute the test, whenever you call the test, it will print this one. The 13 is an odd number. Another example you can see. So this is what our outer function. Okay. And if the value of, if it is an even number, it will return this one, return 1, else it will return 2, this particular function. So f is equal to outer 10. So outer 10 is what? X, the value of x is what? 10, and it's an even number, it will return inner 1. So if you execute x, if you call x, then that means what? You are executing the inner one. We are calling this inner one. It will print x is an even number. That means 10 is an even number. And if you call 13, so it will print 13 is an odd number, 11 is an odd number, and so on. So directly we can call outer. You can see here in this particular example, directly we can call outer. We're passing value. So this 11 is for x and then the bracket. That means what? We are calling outer 11. It will return according to the value present in this. Here it is the number x. So it's an odd. So it will return inner 2. And whenever we are inner 2, then bracket, that means we are executing this inner 2 and it will print that x is an odd number. Closure or factory functions. Already you have seen. Depending on whom you ask, this sort of behavior is also sometimes called a closure or factory function. You just see that. What is this? Just see the program first. So this is what our outer, this is what our inner function. It will return the return inner. And it is returning e to the power x. E to the power x. Whenever you call outer 2, so the value of x is what? It is 2. And f1 holds the inner. Okay. And whenever you call f1, whenever you execute f1 by passing some value, that 3 is nothing for the e. And if you print the result, it will print 3 square, that is 9. Similarly, outer 2, the value of x is what? It is 4. And f23, that means what? That means we are returning, we are executing the inner with some, we are passing some parameter 3. So is the value of a is equal to 3. So 3 to the power 4 is what? 81. So here in each call to make inner creates a new instance. Here value of this function. But each instance has a link to different binding or variables. Each time it creates another instances. Not the same instances. The decorator function is very interesting one. A decorator takes a function as an argument and extends its functionality. Very important. returning a modified functions with the enhanced functionality. The fundamental goal of decorator function is to allow us to increase the functionality of existing functions without having to change them. It allows programmers to change a function behaves. In decorators, functions are passed as a parameter into another functions and then called inside the wrapper functions. It is also known as meta-programming. Here, one portion of a program tries to change another component of the program at compile time. So just remember this one. It allows programmers to change the function behaviors. We can change the function behavior or we can extend the functionality using decorator function. Okay, already you know what is higher order function. Already you have discussed. A function that accepts other function as an argument is called the higher order function. That already you have seen. So just see one simple example of decorator. Uh, just see the initially just first of all just see the higher order function already you know. We have an increment function, we have a decrement function, we have an operation function. In operation function, we receive function as an argument and x. It return cal, where cal holds the function output of the function which we have passed it, and x is the parameter which I have passed as a parameter of this function. So print the incremented operation. Operation is what? Nothing but this particular function. We just pass inc. Inc is nothing but this particular function. We are passing function. We are passing this function where the value of x is what? It is 10. So it will return what? 11. 10 plus 1 which is 11. Since second operation we pass decrement, another function decrement. We are passing this particular function. We just take another. We are passing this particular function. Okay. Decrement function we are passing here. Okay, so according to that we can get, so decrement now it is what? It is 9, and increment of 10 is what? It is 11. Now we can see another example of higher functions. Divide. One function is there, divide x by y. Now we can see outer divide is there, inner is there. Outer divide we are passing function, and inner is what? We are using that particular function and use that particular parameter x and y. Okay, so if y not equal to 0, it will execute, it will return that function with the parameter x and y. And finally, for this outer div, we return the inner. That means we're returning this particular function. Now see, outer div divide. Outer div, that means what? This particular function, outer div, we are passing divide. We are passing divide function. Okay, now outer div will return inner. Outer div will return inner. What is inner? Inner is nothing but this particular function, inner function. It will return inner with, and inner, if you execute inner, it will return the function which we have passes and which we have passes the parameter. So outer div return to return inner, and if you execute divide result with some parameter 2 comma 4, 2 comma 4, so this will for x and this will for y. So we have to execute 2 by 4 using this divide. So 2 by 4 is what? 0.5. Second time we execute this divide 6 comma 2. So x comma y is what? 6 by 2 is what? It's a 3. Okay. Third time it is 6 comma 0. So here 0 is what? So it will not return anything because this condition is not true. So it will not return func x comma y. It will not return inner. So here the condition is not true, that means it will return none. So definitely it will, this function is also return none. So that's why no output is there for this particular function call. Okay, you just see once again. It's a very interesting one. Uh, divide function is there. The task is, it will result is x by y. Okay, it's the outer function. Inside the outer function there is inner function. It will return the function with the parameter passing. So here that means what? Here we return inner x comma y also. Is it okay? That means we're returning what? We're returning func x comma y. Now outer div divide. Outer div, outer div, outer div. We are passing the divide function. The func is what? Func is equal to divide. Then it will return inner. What is inner? It will return inner function. What is inner? Inner holds this particular function, which will return what? Func. What is func? Divide with the value x and y. Okay. So divide result, outer div divide. So it will return divide result. So divide result, hold this one. If you if you pass some parameter 2 comma 4, that means what? Divide 2 comma 4, output will be what? 0.5. If you put 6 comma 2, output will be what? Now instead of, we can change the divide. So instead of divide, if you put mul, suppose there is another function, say mul. Say it is a mul. Okay, and here it is x asterisk y, and here it is a 1 1, and can you put it to, instead of divide, can you put mul here? Okay, and say it is a 2, it's a 2. Okay, and remove it. Can you see the result? Okay, you can see the result. In this function, here we are passing the divide. Same function, we are passing another function mul. So it will return 6 into 2, 12. It will return 2 by 4, it is 0.5. You just see the difference. This particular part, div outer, div function inner xy, you just see this one. Both are same thing. Okay, you just remove this one. Okay, and remove this one, remove this one also. Now we can compare this one and this one. Both are same thing. Is it okay? Yes. Now here the divide function is there, here divide the function is there. Now we just call the divide. We just call the divide and we put 2 comma 4. So it will give the result 2 by 4 is 0.5, no issue. Okay. If you put 6 by 2, definitely it is 3 by 2, no problem. But if it is 5 comma 0, if you don't put anything, the output will be what? Overflow, divide by 0 error. But here it is giving that y should not be 0 here. How it is possible? Because of this decorator. So here outer div is there. We mention outer div as a decorator. So the decorator wrap the function and modify its behavior. Decorator function modify its behavior. So we can see the difference here, how we mention, how we execute, how we call this one, and here how we call this one. This one is much more simpler, clear. Now you can see it is much more difficult to understand. So here is the decorator function. So in decorator, if you write at the rate outer tip, that means what? We just update this particular function. We just modify this particular functions. It will work according to this. Okay. Now what will happen if you what will happen if we remove this one? If you remove this one and you just see the result, you can see 5 comma 0, it's a divide by 0, it gives divide by 0 error. That means what? This function is not working here because we suppress this one. But once you enable it, that means what? We are using this particular function. That means divide is passing through this particular function and we will give the result. And we can execute it and we can get the result. So no divide by erasure is there. Okay. If you want, we can add the print option. Why should not be 0? You can see why should not be 0. But we are calling only the divide function. You can see divide function. So that is called decorator. So can we call more than one decorators? Yes, we can call. You can see here. There's a one display function is there. It is just display x and y value. Another function is there, outer diff. It will check whether y is not equal to 0, then it will return the function. Otherwise, it will y should not be 0. Okay, and here you put at the rate outer diff at the rate display. Okay, and we just define the function x by y. So here we update, we modify this one with the help of these two decorators functions. So we can execute it and we can see the result. So the value of x is 2 and value of y is 4. The result is 0.5. The value of x is 3, 6 and y for this one. So the answer is what? 3. And for this one, y should not be 0. Okay. Now we can, if you suppress this one, we can see the display part is not there. This particular part is not there. It is missing. Okay. If you add it, now once again we can get the display part is there. Now we can suppress this. Okay, so divide by 0 is there because this particular part is not working. Okay, but display are there, display portions are there. So here more than one decorators we can apply. Okay, so enable it and you can run it. Is it okay? We can see one more example. See here, one function is multiplication function, another function is what? Division function is there, and we are passing mul at the rate mul and at the rate div, and it's just evaluate. We are passing calling the function evaluate x and y. So here it will call these two functions as well as it will pass this particular parameter. It will pass this particular parameter. Now you can see evaluate 2, 4, evaluate 6, 2 and evaluate 5, 0. You just see one by one. So evaluate 2, 4 is what? Multiplication is what? 8. Division is 0.5. Evaluation is done. So here we just call evaluate. You just call the evaluate. You're not calling these two functions. But decorators will help to call this one, to use these two functions for this evaluate. Okay, we can use another one also. So these two are the answer. Multiplication is 8. Here multiplication is 12. Division is 3. Equation is 7. Okay. You enable this one also. Multiplication is 0. Why should not be 0? Okay. We can eliminate this one also. There must be one single output. Okay. So this is what our decorator. So please see these programs properly. Okay. And use according to your requirement. Okay, now the final topic is generator function. So it is similar to the normal function defined by the def keyword and uses a yield keyword instead of return. Okay, so already you know in our simple function we use the def, then function name, then parameter, okay, and then return. This is what our simple functions. But in generator functions, there is a def, okay, generator function name, parameters, and here yield. Okay, and one more thing, we can execute more than one yield in a same function, or we can mention more than one yield in a same function. But in particular function, there must be a single return. Okay, now we can see example. So this is what our example one. Now we can see here, this is what our name of the function, my yield. Okay. Now here str first time, str2 second time, str3 third time. So three yields are there, str1, str2, str3. Now here we call the function and we store the object of the function in this obj. And we execute the object of that particular function using the next. So if you execute first time, you can see if you execute single first time, the output is what? The output is what? We can see the output is first time. Okay, first time. So it will execute only this one. Now if you execute same thing two times, so it will execute this one as well as this one. Okay, you can see here. So it will execute first time and second time. Similarly, if you execute third time, we can execute this one. We can get this output. Okay. So is it okay? So I think it is okay to understand the nature of the yield generator function. Now we can see the second example. Here def mygen is the name of the function, and here uh, initialization of the variable n is equal to 1. Now this is what our increment. So initially n is equal to 1. Now this is what n is equal to n plus 2, that is n equal to 3, yield 3. So it will return 3 here. So n is equal to n plus 2. So it is 5. So it will return 5. N is equal to n plus 2. It is 7. It will return 7. Okay. So output is equal to mygen. So this is the, we just call the function and we just store object of the function in output and we execute this output using the next instruction. So if you execute this one, if you execute this particular print operation one by one, so we can see different output. Okay, so we can see here. So if we execute first time, so it is 3. We can execute 1 and 2. It is 3. Okay, is it 3 and 5? If you execute third time, it is 3, 5, and 7. Okay. Next, loop with generator. So we can see here. So def mygen x. This is what our function name. Mygen is the name of the function. X is a parameter, formal parameter for I in range x. Yield I. So here we call the function mygen, and here the parameter is 3. That means this is what our x. Okay, and we store object of this function in my sequence. So here I in range, so the value of I will be what? It should be range x. X is what? 3. So first time it is 0, then 1, then 2. So we can see one by one, we can see the one by one the output, and we can check it. So first time if we execute it, it is 0. So that means what? We are executing this one first time. Second is what? If you execute it the second one, the output is what? 0 and 1. Okay. Now second one. Next we execute third time. So the third time if you execute, then the output is what? It is 0, 1, 2. That means 0, 1, 2. Now what will happen if you want to execute one more time or more than 3 times? So if it is more than 3 times, we can receive an exception message, error message, that is called stop iteration. Okay, it's an exception. So to handle such type of situation, we use try and except. Okay, so we can see handling the stop iteration error or stop iteration exception using try and except. So this is what our function. So def mygen x for I in range 1 comma x yield, and here we call the function so 6. So that means the value of x is what? The value of x is 6. So I in range, the I in range 1 to 6. So 1 to 6 means what? 1, 2, 3, 4, and 5. So my chain, it returns the object of that function, and my squares hold that particular object of that function. So while true, it is infinite loop try, and here we print the next MySQL till the exception stop iteration. Okay, so if it receives stop iteration exception, it will break, it will come out from the loop. Okay, so we can execute it, we can see the output. So we can see here, if you execute it, now we can get the okay, so we can remove it and we can run it, it is okay. Second, this one, if you run it, we can get the output 0, 1, 2, 3, 4, 5. Okay, so here infinite loop is there, but still it execute till 1 to 5, because range it is 1 to x, x is nothing but our 6. Okay, so instead of 3 we can write this 6. Next, now example 5, handling the stop iteration error without try and except. So without try and except also we can execute it. So this is the name of the function. So def my function 1 I in range 0 comma 5 yield x to the power I. So here is the call the function my fun1 2. So 2 is nothing but our x. This is what our x, and then out, and the I varies from 0, 1, 2, 3, and 4. And x to the power I means what? X to the power 0, x to the power 1, x square, x to the power 3, x to the power 4. And if the value of 2 is x is 2, that means what? 2 to the power 0, 2 to the power 1, 2 square, 2 to the power 3, and 2 to the power 4. So that means what? 1, 2, 4, 8, and 16. So 1, 2, 4, 8, and 16. So it is x to the power I varies from 0 to 5, and x is the parameter, formal parameter. So for n, small n, in my fun 1, 2. So my fun 1 is what? We are calling that particular function, and here the parameter is 2. So it will iterate till the size of this I. Okay, till the size of this particular loop. Automatically it will come out from the loop when it exhausted, when the loop is exhausted. Now, what is the difference between general function and normal function? So in normal function contain only one return statement, whereas a generator function can contain one or more yield. Okay. Now local variables and their states are remembered between the successive calls. So that means what you can see here, we can see here the meaning of this. We can see the example. So initially it is n is equal to 1, then we increment it, and now the value of n is what? 3. So if you execute first time, the output is 3. If you execute second time, that means it will remember now the present value of n is 3, not the 1. So that's why it will give the output 5. If you execute third time, now it will remember that the present value of n is 5, not 3 or not 1. That's why it will give the answer 7. 5 plus 2 is equal to 7. Are you getting this one? Achha, there is one question. So can you write in outside the function as a global, and can you execute it? Okay, so please you can try. You just download the program. You can try, and you can mention in here outside the loop and execute. Is it okay? Will it work? Okay. So please mention in the comments box. Give your result. Okay, give your answer. Whether you will what you will get if you execute, if you mention in outside the function. Okay. Now example 6, Fibonacci using function generator. So here you can see we can use Fibonacci number to Fibonacci series to get the Fibonacci number. So this is what our function generation, name of the function. This is what our initialization n1 is equal to 0, n2 is equal to 1, while true it is infinite loop, yield n1. So yield n1, and here you update the variable. Variable is what? N1 is equal to n2, and n2 is equal to n1 plus n2. It is what? Common logic for the Fibonacci series. So this is here we call the function, and we store the object of the function in Fib sequence, and we execute. If you execute one by one, we can get the answer 0, 1, 1, 2, 3, 5, 8, and so on. So we can see the output one by one. Now say if it is say if it is like this one, this one, this one, and this one, and if you execute it, it is 0. First time it is 0 definitely. If you execute second time, first and second, it will be 0 and 1. If you execute third time, it will be 0, 1, 1. If you execute fourth time, it will be 0, 1, 1, 2. If you execute third time, it will be 0, 1, 2, 3, and so on. Next, generator expression. So it is just like lambda expression, lambda function. So x to the power x for x in range. So this is what our first part of the expression, that is the yield value, and this is what our sequence. So in generator expression, here some calculation must be there for x in range. So this will be the yield part, and this will be what? The sequence. So the first part of the expression is the yield value, and the second part of is the for loop with the collection. For loop with the collection. This here should be the collection must be there. So it may be the range, it may be the list, it may be the dictionary, whatever it may be. Okay. Now we can see the one example. So here example 7. This is what our generator expression is, same as lambda function. So list is equal to 1, 2, 3, 4. This is what our collection, and z is equal to square root of x for x in list. So this is what yield part, and for loop with the collection. Okay. So the output will be what? X. So x will be what? X will be 1, 2, 3, 4, and yield should be what? Square root of 1, square root of 2, square root of 3, and square root of 4. Okay. So if you print first time, it will give the output 1. So square root of 1 is what? 1. And if you execute second time, so the output will be 1 and 1.2, 1.4, 1.4 is what? 1.4 is what? Square root of 2. Okay. Similarly, if you execute third time, here we can say it is what? It is 1.73. This is what? Square root of 3. Okay, so this is what our generator expression. So here there is no function name, so we can use z for this particular generator. Okay, so what is the difference between list comprehension and generated expression? So this is the example of list comprehension, x square for x in range 5, for example, and this is what our generated expression. So both are same, here both are same, but generated expression we use this bracket and here we use square bracket. So in list comprehension we use square bracket, in generated comprehension we use first bracket. So if you execute this output, we can get 0, 1, 4, 9, 16. Similarly, if it is till 10, we can get same type of answer. So first time it is, so if you execute this one, first time it is square root of 0. Second time it is square root of 1. If you execute one more time, so it is not square, it is square, sorry. So x square, okay, so second time it will be what? 2 2 square, so 2 square is what? 2 square is what? It is 4. So in list compression it gives all the result at a time, but in generated expression it gives the result when we execute one by one. So it will give the result one by one if you execute that z one by one. Now finally you can see generate infinite sequence. So this is what our function definition, def I is n is equal to 0 while true yield n. In here we update the n. So here it is n is equal to n plus 1, and this is what our initialization of the n starting with 0, infinite loop. We just give the output of n and we increment the n. So with the help of this we generate infinite sequence. Okay, so if we execute it, we can execute it. We don't get any output now, but if you enable it, you can give the result. You can give the result. Now we can see infinite sequence is there. Okay, so definitely we should not continue it, and I stopped it. Okay, so in this way we can generate infinite sequence using generated expressions. Okay, and that is the end of this particular video. Thank you very much.